She lost her earring. All right. So we are going to do 1.6, which is inverse function. Okay? Huh? Yeah, inverse function. All right. So, hey guys, you all tell me everything you know about inverse functions. Do y'all know anything?
I don't remember. They're like opposites.
Like opposite.
Is it 1 over x?
No.
No,
That's a reciprocal. Okay? That's a reciprocal.
Opposites.
Huh? Oh! So, Chris is on something. I almost called you John. I don't know why. All right. So, inverse. Inverse function. Because we're going to say switch the x's and the y's. Alright? Anybody else remember anything? So one guy's domain becomes the other guy's range, and then his range. Yeah, you also switch the y's and the x's.
So really, it's just what?
That was the silly statement. Okay, what? Yeah, so you just switch the x's and the y's.
Same, except for using different letters.
That's right. So what now? Yes, they do have something to do with each other. Okay, they do have something. Anybody remember anything else about it?
Like on the graph, wouldn't they be so they're not exactly the opposite? Like they reflect each other?
They reflect each other. Reflect each other through what?
The y, the x,
The y origin.
The what?
Y equals x.
Yeah, because you switch. That's what I thought he said. Then he wouldn't say it again. Okay? So, yes, they reflect over the y equals x line, which is the identity function. Okay? The y equals x line. Anybody know anything else? Here's the very first thing you need to look at. Okay? First, when they tell me to find an inverse function, the very first thing I do is I make sure he's 1-to-1.
there's 1x and 1y for each one.
There you go. Make sure the function is 1-to-1. Now, what is a 1-to-1 function?
X is over y.
Alright, so that means every x, alright, every x has one y. That's what makes it what? A function. And
Be able to have an inverse
every y has one x. Now look, that's what it has to do to have an inverse function. That's a little bit different, okay? So I don't want to say it doesn't have an inverse. I want to say it doesn't have an inverse function unless it's a 1-to-1 function. So what does it have to pass in order to prove that it's 1-to-1? Okay, so it must pass the vertical and the horizontal line test. So the very first, when they say, hey, find this guy's inverse, I'm going to put it in my calculator and make sure it's 1-to-1. Okay, because if it's not 1-to-1, it's easy to write the answer in the blank, right? Doesn't have an inverse function. That's your answer. So that's going to be the very first thing I'm going to check. First thing, I'm going to make sure it's 1-to-1. Does it pass the vertical and the horizontal line test? Brent?
I'm sorry, this just popped in my head. Are you done taking steroids?
Yeah. Yeah. Finished on Friday. I feel a lot better. I'm getting nice. Yeah, I'm not quite as on edge.
You're not coughing either.
I'm not coughing or anything, so I'm a lot better. No, that wasn't exactly what I gained. But, okay. So, now, let's do, here's something else about inverse functions. Okay? An inverse function. Inverse functions how do you write inverse function? Like if this is f of x, what's its inverse going to be?
X of Y.
F of Y.
No, not X of Y.
With X of Y?
F inverse of x. Okay? F inverse of x. Okay, and here's something else that's true, because this is the way you guys are going to have to do it. When I say prove algebraically or show algebraically that these two functions are inverses, this is what you're going to have to do. You're going to have to show that f of f inverse of x is equal to f inverse of f of x, which are both equal to x. Okay? In other words, you're going to plug one into the other, make sure it's x, and one into the other one into the one, and make sure it's x. Okay? So, and we'll show how to show some of this other stuff. You can also look on your T-chart in your calculator, and I'll show you how to make sure that you haven't messed up somewhere. Okay? How to see if they're inverse.
So if one doesn't equal X, quit.
That's exactly right. Yeah. If they say, hey, are these two inverses of each other, and you find f of f inverse of x, and it's not x, do I need to find the other one? No, because if one of them's not, it's not an inverse. Okay, both of them have to be. All right, so let's try this one. We're going to skip example 1. We're going to do example 2 in your book. Actually, it's not even example 2. I'm kind of making it up, but it's like example 2. If I tell you that f of x is equal to 2x minus 1, this is what I want you to do. Find f inverse of x and show algebraically that it is an inverse. That they are inverses, or however you want to say it.
So, whenever don't you change it to 2x minus 1 is y minus 1?
Hang on just a sec. Okay, what now?
Never mind, that's probably the first time it's working.
No. Alright, so the first thing I want to do, I want to switch the x's and the y's. Well, guys, we got a problem because he doesn't have a y. So what's the first thing I need to do? Yeah, change f of x to y. So y is equal to 2x minus 1.
Oh, what's that?
Okay? Yeah. Now we're going to, we did this in Algebra 2, alright? Now we're going to switch the x's and the y's. Do not, are you listening to me? Do not put it underneath here. Because when you work it underneath here, then someone follows this, they think it's all the same thing. And then all of a sudden you switch the x's and the y's and they're like going, whoa, wait, what happened? So go out here to the side and switch them. So now x is equal to 2y minus 1. Now what are you going to do? Solve for y. So I'm going to add 1 to both sides. So x plus 1 equals 2y. And now what do I do? Divide by 2. So y is equal to x plus 1 over 2. I'm okay with you leaving that like that. Okay? I do want you to write it as its inverse. So I do want you to write f inverse of x is equal to, and you can write it as x plus 1 over 2, or if you wanted to, you could write it as 1/2 x plus 1/2. Just remember that both of them are divided by that number. Okay? So whichever way you want it. I usually go back and kind of box these things in because we're going to come back and use those. Alright? But the first thing I want to do is I want to look at it on a calculator, and I want to show you what it's going to look like. Now, you know it's not a good thing to go by looks, right? So we know that actually just looking at it on a calculator is not your best thing. But, what was it, 2x minus 1?
Yeah.
And the other one was?
X plus 1 divided by 2.
Alright. Okay, so I'm going to graph them. I also graphed the y equals x line, and I made it fatter so you could visually see how that if I folded it on that y equals x line, they do reflect over each other. They reflect over this line. This one would land on this part would land on this part. Okay? Now, a T-chart would tell me even more because he's not going by looks. Oh, I'll tell you this too. When I graphed it, I went zoom 5 and put it on the square graph so it looks better. Okay? But if I looked at the T-chart, what am I looking for on this T-chart to show that these things are inverses? No. What am I looking for on this T-chart?
The picture, the X is or Y. What the 1 to 1?
No.
No.
Yeah, that they're switched. That's all you're looking for. Look, if this one has the 0.35, what should the other one have? 5, 3. Okay? If this one has the 0.1, -3, what should the other one have? -3, -1. Okay? Oh, how about this one? If this one has the 0.11, what should the other one have? 1, 1. Okay? So, everybody understand? That's the point where they what? Yeah, that point where they intersect. 1, 1 on both of them. So that's that point right there. Okay, so anybody got a question? See, looking at it on a graph, I can kind of say, yeah, I think I'm doing pretty good. Looking at it on a T-chart, I can go, oh yeah, I'm right, or, uh-oh, I messed up. Okay? So now let's do what I'm going to make you do, which is show algebraically. So what I'm going to make you do is I'm going to make you find f of f inverse of x and show that he's x, and I'm going to make you find f inverse of f of x and show that he is x. Okay? I'm going to be really, really particular in how you do this, because what happens is that functions and inverses, they undo each other. What one does, the other one undoes. But the order that you undo it is important, so I'm only going to let you do one thing at a time. Okay? So, first I'm going to put this inverse function in here. So I'm going to find f of, I'm going to put, what do you want to put? X plus 1 over 2? X over 2 plus a half? Okay. The other one will be faster, but it doesn't really matter.
I'll try to do it faster.
It doesn't matter. It's all the same. Alright, so now I'm going to the f function. Here's the f function. In place of this x, I'm putting this mess right here. Okay? So I got 2, uh-oh, there's an x. You got to write that stuff in there. So x plus 1 over 2. And then you have minus 1. Alright, so here's where I'm going to be really particular. So, because here's what's going to happen. You know what the answer is supposed to be, people. Okay? It's supposed to be x. So what do kids start doing? Slash, 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 slash. X. It's x. Like, no, you can't do that. Can I flash the plus 1 and minus 1 right now? You can't, guys. Okay? These are the only two that you can, only two, or one pair, whatever you want to look at it, that go away. Now it's x plus 1 minus 1. Now can I slash the 1? Yes. And so there's my answer, x. I'm not going to let you do this. If you do this, I'm going to say minus 2. Okay? Because I can't tell which one you wrote first. Alright? I know what you're going to say when I call you up there, but that's not, I told you not to do it. Alright? So, now we're going to do this one. We're going to put this function into here. So that's f inverse of 2x minus 1. So he goes up here. There's my x. 2x minus 1. Plus 1. All over 2. Listen to my question. What can you not slash right now? Very good. Now you cannot slash those 2's. Okay, the only thing that you can slash is these. And then you're left with 2x over 2. Then you can slash the 2's, and that leaves you with x. Okay, so this is showing algebraically that they are functions. Do I have to do both of them? Yes, you can't just do one. Okay, anybody got a question?
Will one work and not the other?
If it's not a function sometimes, I mean, if they're not inverses of each other, then yes, sometimes one will work and the other one won't. Okay, you try one. You ready? This is example 3. Yeah, it's the last one. F of x is equal to 2x to the third minus 1. Here's what I want you to do. I want you to find this. And show algebraically that they are inverses. Pardon me. Thank you. Okay, so I'll give you a couple minutes. You do that. Yes. What you take the cube with the x? Well,
No, it says
he'll be with the y. I mean, when you y. I misunderstood your question. I'm sorry. I misunderstood your question. I thought you meant when you just took it over here, like it's going to look like this.
you do. You just
So then you're just going to switch them. So this is going to be an x 2y cubed minus 1. So don't pull him over there with the x. Just leave him where he was.
is that how it works? Yeah,
No, that's right.
oh, that's right.
I don't even know how to put that in the calculator.
I'll show you.
You just put, look, there's another
3.
button.
Yeah, just the way you say it. 3, that's cube root, so press a 3, and then press math, and choose number 5. Number 5 lets you take any root that you want.
Yeah.
Yep.
I don't think it's gonna work.
You don't think it's going to work because of the horizontal line test? How many people did the vertical and horizontal line test before they started working it?
I'm going to.
No, one person? 2 people? 2 people? It should work. It's cubed. It should work. Does that mean all cubes work?
Not all of them.
Not all of them.
I don't know.
That one does.
That one does. You're right. That one does. But you can't say all cubes work, right? Because this is a cube. And does he pass the vertical and horizontal line test?
No.
No. But this one's not going to do that, is it? No.
That
Because
was
all
just-
the 2 does is a...
Yeah, that was just
What
some
is it?
information of the vertical.
It's a vertical stretch of 2, so my little cubic curve is going to be a little bit steeper. And the minus 1 just does what to him? Moves it down 1. Okay? So yes, he does pass the vertical and horizontal line test. He is one-to-one. This function.
Any more x's in it? It's always going to just.
Yeah. If it doesn't have any of the x squares and x's and stuff like that, he's going to do it. There he is. He passes it. It means it has an inverse function. You just need to find it. It does look cool. Can I take the cube root right here?
No.
No. You have to get that y by itself. Very good. Alright. So now I get y cubed is equal
You think
to...
we do that all in one?
Yeah, you could have done that all in one. I would have. Cube root. Like I would have taken the cube root up here. So y is equal to the cube root of x plus 1 over 2. So that's the f inverse of x. Is that what y'all got? Okay. I do like to go and check it out first on my calculator just to make sure I'm okay. So I'm going to go to y equals. This is the way you put it in if you don't know. It's however you say it. That's called user-friendly. If you ever worked with an old calculator and you want to take a square root, you have to put the number in and then press the square root button. It's very confusing for y'all, okay, but that's the way our calculators always were when we were growing up. So the cube root, so 3, and then if I press the math button, number 5 lets me take any root that I want to. I choose number 5. Y'all's fancy calculators pops that 3 up there as the index number. Mine won't. And then I got to use a bunch of parentheses on mine. No, because the school got in a fight with PI or something, and they won't. They said we already paid for it, and then when we got new calculators, they wanted us to buy it again, a site license, and they said no, we're not doing it. We've already paid for one. So I don't know. I would assume it is because
Probably
it means
$2.
anybody in this site. Anybody on this campus could use it. So it allows all of the teachers, not on this campus, I'm going to bet they buy one for the school district. So all the teachers
For like $2, that's not $2.
Oh. Okay, so now I'm going to graph it.
I don't have enough money for that. $2 more than
There it is. That's pretty cool. Notice that the regular cubic function, he kind of snakes around the y-axis. Look at the cube root function. What does he snake around? The x-axis. Okay? You'll notice that this part right here, if you folded it on the thick line, the y equals x line, he would reflect over on top of this. This little hump right here would reflect on that, and this little part would reflect on that. Okay? So, you can look at your t-chart, and you can say, hey, I think I got something. I got 0, -1, and -1, 0. Notice that this one's not as easy to find things to check, okay? So, I mean, -1, -3, and -3, -1. Did we already do that one? No. We did 0, -1. Alright, so then they get kind of big and crazy, but anyway, looks good. So now let's show algebraically. Algebraically, you're going to show that f of f inverse of x is equal to x, and f inverse of f of x is equal to x. Now, when you do these, this is where you start seeing how things like cancel each other. What one does, the other one undoes. So this one's going to be, I'm going to plug this into that. Okay? I'll plug this into that. F inverse goes into the F. So 2 times the cube root of x plus 1 over 2. I'm raising it to the third power. And then I'm minus 1. Yeah. The first thing that happens is the cube roots and cubes cancel each other out. So now you're left with 2 times x plus 1 over 2 minus 1. Now who cancels? The 2. And then you're left with x plus 1 minus 1. These cancel. So there's my answer. On this one over here, this one, I'm going to plug this function into this function. So he looks like this. The cube root of, there's my x, that's what I'm plugging in. So 2x to the third minus 1 plus 1 divided by 2. Do the 2's cancel out? No. The 1's cancel. So now I got the cube root of 2x to the third over 2. Can I take the cube root right now? No. You have to cancel the 2's out. Now you have the cube root of x to the third, which is, and there we go. Okay? I'm going to be very particular in how I grade this, guys. If you just start slash, 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 yep, x, then I'm going to go. That person didn't know what they were doing, and I'm not giving you credit for it. Brent.
Is there any real world application of this?
I started a phenomenon.
That's what you're saying?
No, I said I started a phenomenon. I'm doing the F that I never see things always ask for that every time. That's my mark on this one.
Oh, yes, of course there are. Yes. Okay? Of course there are.
We have to solve.
Shut up. Shut up. Okay. So, yeah. Oh, yeah, you know there are word problems, people. Please. There's a bunch of word problems. Okay? Your hourly wage is $8 per hour plus 75 cents for each unit produced per hour. So your hourly wage, Y, in terms of the number of units produced, is Y is equal to 8 plus 75.75x. 75 cents. Did I say $75? Cents. Okay. So it's 8 plus 0.75x. Find the inverse function. What does each variable in the inverse function represent? Use a graphing utility to graph the function and the inverse function. Use the trace feature of a graphing utility to find the hourly wage when blah, blah, blah. Okay? So here's what it says. Inverse functions can be helpful in further explaining how two variables relate to each other. What are they talking about there? For salary and how many hours or how many units you have to produce. Okay?
No.
Investigates the relationship between hourly wage and the number of units produced. Okay? So, yes, it does have to do with real life. It's an amazing thing.
Thank you for watching this video.
Thank you for watching this video. Signing off now.